Hi all. Again, this is the continuation of axisymmetric element which is discussed as a derivation. It's the second part of same axisymmetric element, but here we are going to discuss about the problems which are all solved in the three different type of problems. That is, number one, the nodal coordinates for the triangular element R. R1 is equal to 20 mm, Z1 is equal to 40 mm, R2 40 mm, Z2 40 mm, R3 Z3. So these six values are given. That means we are having a triangular element. We don't know whether it may be a axisymmetric triangular element or other ordinary two-dimensional triangular element. We don't know about that. But how we can be, it can be identified because in other remaining triangular element this constant strain triangular element is also the triangular element, isn't it? So how can we identify this one as a axisymmetric triangular element? So for that reason we are concentrating on the very important one is that is R1 Z1 R2 Z2. That's a very important thing. So that with the help of this R1 and Z1, so R2 Z2 R3 Z3, so these coordinates which helps more, then we are having it is if the triangular element has R1 is RZ means then that should be the axisymmetric triangular element. Whether they may be mentioned in the problem or not, then we have to keep it as in our mind. Okay, so in this problem, what is the question? We have to find out the B matrix. So here they didn't describe what is the B matrix. Okay, that means strain displacement relationship matrix. And so already we are they given the R1 Z1 R2 Z2, all the coordinates are given. So from that we are going to find out the value for B matrix. So initially we have to plot the given coordinates as a picture. Then we have to write the B matrix formula. That means 1 by 2a into beta 1 0, beta 2 0, beta 3 0. And here the term, just keep it in mind, that means alpha 1 by r plus beta 1 plus gamma 1 z by r, then 0, alpha 2 by r plus beta 2 plus gamma 2 z by r, 0, alpha 3 by r plus beta 3 plus gamma 3 z by r, 0, and the remaining alternating order. Okay, 0 gamma 1 0 gamma 2 0 gamma 3, then gamma 1 beta 1 gamma 2 beta 2 gamma 3 beta 3. So here no value should not be repeated. Okay, any kind of value should not be repeated in the same column, it should be simply skipped. Okay, so that's why I mentioned this arrowhead. Gamma 1 mean in the third row second column, and fourth row first column the gamma 1 is going to be raised. So like that is going on. So just keep it formula in your mind. Then we know the area of the triangle, that means A is equal to 1 by 2 into the modulus of 1 R1 Z1 on R2 Z2 R3 Z3. So from that we will find out the value. My dears, don't forget to put the units. That's a very important thing. And here we have to find out the R value. R is equal to average, R1 R2 Z, Z is the average. Then what about the alpha 1? Alpha 1 is equal to RZ minus RZ, that means 1 2 3, alpha 1 is equal to R2 Z3 minus R3 Z2. Yes, very good. So whatever may be the formula which was kept into your mind, just use your shortcut, and by these values we will get that remaining alpha 1 by r plus beta 1 plus gamma 1 z by r. So we will get that values, and applying all those values in the B matrix, so we will get it. That is our first equation. We will get it as B is equal to 1 by 2a. That means we will applying all the values, then by using the ordinary multiplication we will get the value of B is equal to, we will get the strain displacement matrix. Okay, so that's the first problem. And the second problem, that means for it's another one different type, that is for the given element determine the stiffness matrix. That means in the first problem they mentioned the notation, they didn't given the description, but here they give the description but we didn't know about the notation. So stiffness matrix capital K within the square box. Okay, right guys, let the Young's modulus and Poisson ratio were given. Suppose in your problem they didn't given the E and V value, just assume yourself. Okay, so but it should be highlighted in the box. For the given figure we are going to, for this figure we are going to find out the stiffness matrix. So here they gave the coordinates. So for node 2 50 is at 0, for node 3 0 50, for node 1 it is a coordinate 0 comma 0. So that's the logic. And now, so R1 Z1 is equal to 0 comma 0, R2 Z2. So we are going to listing out all the coordinates, then Young's modulus value, and just be ensure that the given units are in the same or any other different one. Okay, so here all the units are in mm, so that we will thoroughly we will proceed the next step. Therefore, what is our question? We have to find out the k. So k is equal to 2 pi ra into bt db into b. So first we have to find out the value of B matrix, next we have to find out the value of D matrix, then as usual we will applying all those values, we will get the stiffness matrix K. So first initially we are going to find out the value of area of the triangle, say axisymmetric triangular element. A is equal to 1 by 2 into, okay, so by using the ordinary formula you may use it, or 1 by breadth and height BH, okay, or otherwise we may use our determinant of 1 by 2 into determinant of 1 R1 Z1 or R2 Z2 1 R2 Z3. So like that it is going on. Why here it was used means it's a what's that, equilateral triangle. So that here they use directly as a, they make it as a, this as a B and this as a H, so that they will directly took it. Okay, right. And coordinate R, the average of R, and Z, the average of Z1 Z2 Z3, right? And what about the D matrix? So applying the formula of D matrix, so we will get the value. And what about the B matrix? So by rearranging D matrix we will get it. And what about the B matrix, strain displacement relationship matrix? So B is equal to 1 by 2a into in terms of these values. And finally we are going to find out the alpha 1, alpha 2, alpha 3, beta 1, beta 2, beta 3, gamma 1, gamma 2, gamma 3, like that it is going on, my dears. And finally, if we are simply putting all the values, substituting all the values in that B matrix, we will get this particular solution. So substituting all the values, so B is equal to 0 0.02 into, so this particular values are there. So whenever you are going to frame a matrix, just keep it in your mind, the values inside of the matrix should be as much as minimum, then only it will be easy for the further matrix algebra or matrix operation. Okay, where maybe addition, subtraction, like that. So now we are having the dB, that means dB, we are multiplying the dB into matrix. See the size of the matrix before you are going to doing the matrix operation, whether maybe addition, subtraction, so be careful. So finally we will get this value. And now we are using another one term bt, that means already we know B, so by the transpose we will get the bt. So all the three matrices are going to multiply, these values are substituted here. K is equal to 2 pi ra into bt db into db, right? So here we are supplying, or we are applying all the values, we will get the K matrix as in terms of Newton per mm. So this is the another one different type of problem. And the last problem, that means 3 by 3, we will get it as for the given element determine the stress. So in your first problem we discussed about the B matrix, second problem we discussed about the K matrix, and the third one is we are having the stress. Okay, so what all the stresses are there? Immediately whenever you are hearing the stresses in axisymmetric element, then we have to keep four important stresses are there: radial stress, circumferential stress, longitudinal stress, and the shear stress. So be careful how it will be identified as a axisymmetric element. See here the displacement u1 w1, okay, uw was given, otherwise they will give rz, coordinate means rz, displacement means uw. From these data we will identify the given triangular element as a axisymmetric element. This is the shortcut to keep it in your mind, my dears. So this is a problem, and here we are having the Young's modulus as usual and the Poisson's ratio, and they gave the nodal displacements u1 to w3. Okay, so we are plotting all those, we will get the diagram. And now list out all the given datas R1 to Z3, and nodal displacements u1 to w3 in terms of Young's modulus and the Poisson's ratio, and which is going to be found. So we are having four stresses, okay, sigma r, sigma theta, sigma z, and tau r z. But governing equation for sigma is equal to dB into u. Sigma is equal to sigma r, sigma theta, sigma z, tau r z. So that dB into u, displacement is u1 w1, u2 w2, u3 w3. So already we know these values as a given data. We are going to find this, and we have to calculate these two. Okay. So now what about the area of the triangular element A, and what about R and Z, and what about the D matrix, stress strain relationship matrix? So finally, what about the strain displacement relationship matrix? So finally, B matrix was obtained. So what about the D into B matrix, and what about the dB matrix was found? After the finding the dB matrix, we are substituting all the values in the first equation. So we will get the four values. Okay, we will get the four values. What are the four values? That is radial stress sigma r, and sigma theta, sigma z, and tau r z. So units are Newton per mm square. So whenever we are going to finding the values, after finding the values, we have to must put the unit. And here another two important different type of problems are available. One is the fluid flow within a tube. That is a very important problem. So just seek in your book. That is a very important problem. That means fluid flow inside a tube. Another one problem is there. That is the thermal stress problem. Okay. So alpha into delta t 0, alpha delta t, like that one problem is there, isn't it? F is equal to. So these two problems has a reference, just make it and be relaxed. Okay, so thank you so much for your patience, and do well. All the very best, my dears. So again, if you